All right, let's talk about modern software. Really talk about it. We're going to peel back all the layers, starting from the very heart of the Linux kernel and go all the way up to the cloud. The goal? To figure out how the heck these massive, scalable apps are actually put together.
You hear it all the time, right? Apps that can handle millions of users running on any cloud you throw at them. But how? How does that really work? What's the secret sauce that makes an app so portable and lets it scale up instantly? Well, it all kicks off with a particular way of thinking, a design philosophy.
And that end goal, what we're all aiming for, is something called a cloud-native application. Now, this is a super important distinction. It's not about just taking an old app and dumping it in the cloud. No, this is about building an application for the cloud from the very beginning. We're talking design from the ground up to be portable, to be deployed all the time, and to scale without even breaking a sweat. And the whole thing is built on top of one key piece of tech.
And that piece of tech? It's the Linux container. This is the bedrock, the fundamental building block for pretty much everything else we're going to talk about. So, what is it really? It's actually a lot simpler than you might think.
Okay, so first get the idea of a virtual machine out of your head. You know, those big, heavy things that have to pretend to be a whole computer with its own operating system? Yeah, a container is not that. It's way cooler. At its core, a container is just a normal process running on your main Linux system. The magic trick is that this process lives in its own little bubble, and it's given the illusion that it's the only thing in the universe. This makes it ridiculously lightweight and super fast.
So how does this illusion work? It's all thanks to two incredibly powerful features that are baked right into the Linux kernel itself. Let's stick with an analogy. Imagine you're giving an application its own private, fully furnished office. First up, you have namespaces. These are the walls, the door, the windows. They provide the isolation. Inside its namespace, the process has its own private view of everything. It can't see any other processes running on the machine or mess with the network. It's totally walled off. Then you've got cgroups or control groups. Think of these as the utility meters for the office. They set the resource limits. You can tell the process, hey, you're only allowed to use this much CPU and this much memory. Together, these two things create this perfect, secure, efficient little workspace for our app.
Okay, so we've got the tech containers. That's the how. But what about the what? What do we build? How do we design our apps to really shine in this containerized world? For that, we need a blueprint. And that blueprint is a set of guiding principles called the 12-factor app methodology.
Now, this whole thing was cooked up by some smart folks at Heroku way back when, but it's basically become the Bible for building modern cloud-native apps. It just nails what it takes to build for this new world. There are 12 factors in total, but we're not going to go through all of them. Let's just zoom in on 3 really crucial ones that containers make, well, super easy to follow. First up, store config in the environment. This is all about separating the stuff that changes from the stuff that doesn't. Your code, that should be solid, unchanging. But your configuration, database passwords, API keys, that kind of thing, that stuff changes all the time, depending on whether you're in development, testing, or production. So the idea is you bake none of that into your code. Instead, you inject it from the environment. This lets you use the exact same container image everywhere, which is a massive win. Okay, next principle. Strictly separate your build and run stages. This is huge. The mantra here is build once, run anywhere. You create your container image one single time. That's it. That exact, unchangeable file, we call it an artifact, is what gets tested, scanned for security holes, and then promoted from one environment to the next. The confidence this gives you is incredible, because you know for a fact that what you tested is what's hitting production.
And the last one we'll touch on, run your app as stateless processes. So, what does stateless mean? It means the container itself doesn't hold on to any important information. You have to think of containers as disposable. They can be created and destroyed in a blink of an eye. So if a user's session data is stored inside one, and that container dies, poof, it's gone. Instead, you store all that state somewhere durable, like a database. That way, you can spin up 100 new containers or kill 99 of them, and it doesn't matter. The user experience is totally seamless.
All right, so we get the theory, right? We have the core tech and the design principles. But what tools do you actually type commands into to make this happen? Well, today, the two biggest names in the game are, without a doubt, Docker and Podman. The absolute biggest difference between these two comes down to their architecture. See, Docker uses what's called a daemon. It's this background service, Dockered, that's always running, usually with really high privileges, and it's the central brain managing everything. When you type Docker run, you're not actually running the container. You're just sending a message to that daemon, telling it to run the container. Podman? Totally different story. It's daemonless. When you run a Podman command, it just runs the container directly. There's no middleman, no central service, which gets rid of a single point of failure.
And that one architectural choice has some massive knock-on effects, especially when it comes to security. Because Podman is daemonless, it's designed to run containers as a regular, unprivileged user right out of the box. We call this rootless mode, and it is a huge security win. Now, you can get Docker to do this, but it's not the default, and it can be tricky. Podman's approach just naturally gives it a smaller attack surface, which is why it's become a favorite in really secure environments and for anyone working deeply with Kubernetes.
Okay, we've covered the foundation, the blueprint, and the tools. Now let's get into the craft. Let's talk about a really cool, advanced technique that ties all of this together and lets you build some seriously optimized applications.
This technique is called a multi-stage build, and it's a perfect real-world example of that separate build and run stages principle we talked about. Here's how it works. In the first stage, the builder stage, you use a big, beefy container image that has all the tools you need to compile your code. Think of it as your workshop. So for a Java app, that means the full Java development kit. Once your application is compiled down into a single file, you're done with the workshop. You then start a totally fresh, new second stage. This final stage is based on a super slim, minimal image that has only what's needed to run the code, like the tiny Java runtime environment. And the last step? You just copy that one compiled file from the workshop stage into this tiny final stage. All the tools and junk get left behind.
And the results? Whoa, they are seriously dramatic. Just look at this. If you do it the old way, a single-stage build where you package up everything, all those compilers and libraries, you end up with a huge image. In this case, 880 megabytes. But with the multi-stage build, you throw all that unnecessary stuff away, and look, the final image is less than half the size, down to 428 megabytes. That's not just a small improvement, that's a game changer.
So what does that actually get you? Well, a smaller image deploys way faster. It's less data to push around. And just as important, it's more secure. Why? Because you've stripped out all those extra tools that an attacker could potentially use if they manage to break in. And that is the whole point of building for the cloud, making things lean, efficient, and secure.
So there you have it. From deep-down kernel features like namespaces and cgroups, all the way up to design philosophies like the 12-factor app, you can see that building modern applications is this really cool, layered craft. It all fits together, which really brings us to the one question you should be asking yourself about your own projects. Are your apps just happening to run in containers, or are they truly built for the future, for the cloud?